Lesson 5-7, graph a linear inequality in the coordinate plane. So in this video, we're going to review what a linear inequality is, and then be able to graph the linear inequality on the coordinate plane. So a little bit of some background knowledge. A linear inequality in two variables is just a linear inequality graphed on a coordinate plane with shading for the solutions. So you're going to have your x and your y variables. So think of it as a linear equation, but instead of the equal sign, you're going to have an inequality symbol. The boundary line, so the line that you do graph, is a line that separates the two half planes. You're going to use a solid line if the equation inequality includes the line, the solution is included on the line. You're going to use a dashed line. So a dashed line just means that the solution is not included on the line. So think of this as when you're graphing on a number line, you have an open circle for greater than or less than, and then you have a filled in circle for the greater than or equal to or less than or equal to. And then the third part is you're going to want to choose a test point to determine which side to shade in. And then I would recommend using 0, 0, unless that is on the line, then I wouldn't use that one. But 0, 0 is an easy number to substitute in for x and y to determine if the inequality is true. Because whatever side the point is true is the side that you're going to shade. Now let's take a look at our first example. Here we want to graph this inequality. And when you're graphing these, the easiest thing is to put them into slope-intercept form. So here I'm going to subtract 4x on both sides. And this gives us a negative 2y is less than negative 4x minus 1. To get y by itself, I'm going to divide by negative 2 on both sides. And since I'm dividing by a negative with inequalities, I have to flip the symbol, so now it's greater than. Negative 4x divided by negative 2 is a positive 2x. Negative 1 divided by negative 2 is a positive 1/2. So now here I'm going to graph this part right here on the number line, or on the coordinate plane. So I have a point at 1/2. So roughly here. And I use a slope. It's a positive slope, so it's going up and to the right. So if I go up to the right one, I'm going to have a point roughly here, or I go down to 1, 2 to the left one, which would be roughly here. And if I were just to continue that, you can start seeing where my line's going to be. Okay, since it's got the greater to the symbol, it's going to be a dashed line. So I'm going to do a dashed line. So anything that lands on that line is not a solution. Now for the shading part. The shading part, if I choose 0, 0, and since this one, actually if I put 0 in for y and 0 in for x, I'm now going to have 0 is greater than 1/2. 0 is not greater than 1/2. So this is actually to the left of the y-intercept. So for this one, I may have to, so if 0, 0 is not a solution, I'm not going to do the one underneath. It's got to be above the line, so everything is on this side. So another thing you can think of is when it's greater than, it's got to be above the line. Less than means below the line. And to do that very quickly, to show you, if it's a vertical line, this is less than, this is greater than. If it's a horizontal line, this is the greater than side, this is the less than side. If it's a positive slope, this is greater than, this is less than. If it's a negative slope, this is greater than, this is less than. So now let's take a look at another example. Here it says graph x is less than 1. So this means it's going to be a vertical line because it crosses the line at the x-axis at 1. It doesn't have the equal to part, so this is going to be a dashed vertical line. Less than means it has to go to, it's going to be on the left side, so everything over here is less than -1, or less than 1. So now if I put 0 in for x and 0 in for y, is 0 less than 1? Yes, 0 is less than 1. 0, 0 is here, which that's the side I need to shade. Next, graph this one. Here I need to subtract x on both sides. And now I'm left with y is greater than -x plus 5. Plot the point, so I have a point at +5 on the y-axis. Has a slope of -1, so that means down 1 to the right 1. So it just keeps going down this direction, or it goes up to the left. Now it does not have the equal to, so this is going to be a dashed line. And then the point 0, 0 is right here. So if I test that in, if I put 0 in for y, that has to be greater than -0 plus 5. Is 0 greater than 5? No, this is not. So where the red point is, that's not a solution. That means that everything on the other side is the solution. Here we want to graph y, 2y is less than or equal to 5, so I'm going to divide by 2. And y is going to be less than or equal to 2.5 or 5/2. So 2.5 on the y-axis would be roughly here. It's going to be a horizontal line because there is no x. And it's going to be a solid because it can equal, it has the equal to symbol in it. So this would be a solid horizontal line. Now greater than or less than means below. So everything below here would work. Now to prove that, if I put 0 in for y, 0 is less than 2.5, which is true. 0, 0 is right here, so that's the side I shade. Next, graph this one to get, I'm going to rewrite this. This is really saying y is less than or equal to 3x. So the point is at the origin, 0, 0. And then the slope is a +3, so it goes up 3 to the right 1, up 3 to the right 1, or you can go down 3 to the left 1, down 3 more to the left 1. It has the equal to symbol, so this would be a solid line. Now it has to be less than. Less than is underneath the line, so that would be everything on this side. Now I can't use 0, 0 as my test point because it goes through it. Although I can do it for this one because it does, everything on the line would work, but then I don't know which side to go to. So if I choose 1, 1, so if I put 1 in for y and 1 in for x, 1 is less than or equal to 3. 1, 1 is going to be right here, so that's the side that I shaded. Next, we need to graph this inequality. So I need to get y by it, or get the variable by itself. So I'm going to add 6 to both sides. And I'm left with -3x is greater than 6. Divide by -3. And x is going to be greater than -2. So I put a point at -2 on the x-axis. There is no y. So this would be a vertical line. And it's going to be a dashed line because it doesn't have the equal to symbol. It cannot equal it. And then it says it has to be greater than. Greater than means goes to the right. So everything to the right of it. To prove it, I'm going to use 0, 0. 0 is greater than -1, so that's the side I shaded. Next, here we want to determine whether or not the ordered pair is a solution of the linear inequality. So all I have to do is plug this in for x and y to see if it's true. So when y is 4, does 1 plus 3 work? Is 4 equal to greater than 4? No, because it can't equal 4. So no, that one's not working. If I put 2 in for y, so 3 times 2 has to be greater than or equal to negative 9. 3 times 2 is 6. 6 is greater than or equal to negative 9, so yes, this is a solution. Next, check this one out. So if I have 2 times negative 2 minus 4 has to be less than or equal to 6. So this is negative 4 minus 4 less than or equal to 6. This gives us negative 8, which is less than or equal to 6. So yes, this is a solution. This next one, I have 3 times 7 halves plus, actually this would be 1 half. And then 2 times 7 halves. And this has to be less than 9. 3 times 1 is 3, divided by 2 is 3 halves, or I'm going to do is decimal 1.5, plus 2 divided by 2 is 1, 1 plus 7, or 1 times 7 is 7. Is that going to be less than 9? This is going to give us 8.5, which is less than 9. So yes, this is a solution. Next, we want to write down the equation of the boundary line in slope-intercept form for the equation each line as a dashed or solid. Then describe it if the line is dashed or solid. So here I'm going to add x to both sides. Now we have 2y is less than or equal to x plus 6. Divide by 2. My inequality would be y is less than or equal to 1/2 x plus 3. And this one is solid. And it's solid because it has the equal to part in it. Next, I need to subtract 6x on both sides. This gives us 3y is greater than negative 6x plus 9. Divide everything by 3. I now have y is greater than or equal to a negative 2x. Actually, there's no equal to on this. That was my negative. So just is greater than negative 2x plus 3. Since it doesn't have the equal to, this is going to be dashed. Next, write the boundary line for these. So here I need to subtract 3x on both sides. Negative y is less than or equal to negative 3x plus 4. Divide by negative 1 on both sides. And I have y is now greater than or equal to, I had to flip the symbol because I divided by a negative, 3x minus 4. Since it has the equal to, this would be a solid line. Next, I'm going to add 2x to both sides. And this gives us y equals 2x. Or not equal to, this would be greater than or equal to. And since it's got the greater than or equal to symbol, this would be a solid line. And this next one, Lee has $220 to spend on shirts at $22 each and pants at $38 each. What inequality represents the possible number of shirts and pants that he can buy? Find at least 3 possible solutions. So we need 2 variables. I'm going to use x for shirts and y for pants. So that would be 22x plus 38y. And it has to be less than or equal to 220. It can equal it because he has $220 to spend, but he can't go more than that, but he can spend less than that. So that would be our inequality, but if we were to put this in slope-intercept form, I would just have to subtract 22x on both sides. And we would have 38y is less than or equal to negative 22 x plus 220, divide everything by 38. And then now if I were to go to my calculator, I'll show you how you can graph this on your graphing calculator here. But first, let's rewrite this as in slope-intercept form, so simplified form. So we got negative 22, divide that by 38. And that gives us negative 11/19. So let me write that part down. So y is less than or equal to a negative 11/19 x, and then it'll be plus, and if I divide the 220 and 38 by 2, that's going to give us 110 over 19. So now let's go back to our calculator. I'm going to hit the y equals, and I'm going to have negative 11 divided by 19. That's our x coordinate, or our x, plus I have 110 divided by 19. And if I were to hit, go to the far left of the y equals, and right here it's got to be below the line. So if I hit enter, I want it the lower left shade or triangle here. So now if I hit graph, you can see everything underneath would be a solution. So now let's go to the table. So if I go second graph, we need to choose a couple points. We can't have negatives, so we're not going to have a negative in there. So let's just choose 3 possible solutions. For this one, let me go to the table sets. Let me just go out of here. We know it's got to be above, below that line. So let me go back to that calculator. Everything in the shaded area here. So the y-intercept, it's going to be 110 divided by 19. So let me get out of here. So 110 divided by 19. It's going to give us 5.78. So let's say if you choose, you could have zero shirts. If you have 0 shirts, you could have 5 pants. You could have 1 shirt. You could also have 4 pants. And you could have 2 shirts. You could have 3 pants. Now you could check that by plugging those numbers in for here to see that it has less than $220. Otherwise, these would be a couple options you would have. So if I did 5 times 38, let's just do that on our calculator. 5 times 38 gives us 190. And if I had 22 plus 4 times 38, that still gives me $174 total, which is still less than 220. So that is our lesson on graphing linear inequalities in the coordinate plane.